Paris Agreement is very much in the news. Countries have pledged to reduce their CO2 concentration in order to maintain global temperatures at 2 degrees above pre-industrial level. This figure shows the CO2 concentration as a function of time. The colors show the top 4 emitters, the USA, the European Union, India, and China. The black line is the global total. So if you focus on after 2015, the black line shows the emission pathway we must be on to achieve that 2-degree target. And obviously, very ambitious reduction schedule is very much needed. Country emissions are self-reported. So my challenge is, how do we know if the countries are maintaining their pledges, and how can we encourage them to do better than their pledges? So we know speed limits are effective if there's feedback, and the radar gun is a very effective feedback. So a model for treaty verification must be trust but verify. So the Jet Propulsion Laboratory has developed a new instrument called the Orbiting Carbon Observatory, OCO. That's the chemical formula for CO2. So the OCO uses reflected sunlight to measure the number of molecules of CO2 and oxygen in the pathway. It's really cool. The pixel is 3 square kilometers, and the satellite's going at 7 kilometers per second to give us a view of CO2 of the entire globe. The CO2 OCO was scheduled for launch for 2009. Unfortunately, the rocket, instead of going up into space, went down into the Southern Ocean. So we all worked to argue for reflight, which was approved in 2010. So the rationale for the reflight was climate treaty verification. Here we go at Vandenberg Air Force Base. And so the reflight was scheduled for launch at 2:56 in the morning on July 1st, 2014. I was out there in the cold California fog. I was grateful for the hot coffee supplied by the food trucks. But unfortunately, the launch was aborted 40 seconds before target because there was a valve wasn't working. So lucky for us, it was quickly replaced, and we have a successful launch the following day. So this is the first picture. It's very exciting to me, the first picture from the satellite. And you can clearly see that Pasadena, the urban part of LA, has much higher CO2 concentration than Edwards Air Force Base. So my challenge is, how can I use this data, this marvelous set of data, for treaty verification? So we at Berkeley have been developed a new mathematical system to do just that. So in the model, I asked the question, suppose China, I can pick any country, has underestimated its emissions. It is a large country, and comprehensive surveys are very difficult. So can we tell using the satellite data? And it's very exciting. Here is what the model tells me, the extra CO2 needed to match the observations. So you can see the red region over China is clearly showing us that that country was underreporting in the hypothetical experiment that I carried out. And the blue means no worries within the uncertainty of the system. When I sum up the extra CO2 for 4 large regions, what we see is that for East Asia, that's the red bar, that we can recover the missing emission. So it's not totally clean at the moment because how CO2 is blown around depends on the wind. And so we know that weather forecast models are not yet perfect. And so there's still uncertainty that we're working on. But we're really excited. This is the first demonstration that the satellite data are useful for retrieving emissions of fossil fuel CO2. So we're very encouraged. So OCO2 now is flying at the head of a constellation of satellites we call the A train. A for afternoon overpass time. Okay, so you can see between the first and the last one, it's very short time. So the A train is measuring the CO2, the temperature, the water vapor, the clouds, the aerosol, the ozone, and everything. So now we have a very good monitor, not just of the CO2, but of the health of the planet. Looking forward, OCO2 is scheduled to be on the space station. And so what we also have is GeoCarb is also approved to be on a geostationary satellite over the Pacific. So we are very excited. We hope that the radar gun that we have developed at Berkeley will contribute to treaty verification and the health of the planet. Thank you very much.